This project's going to be a bit different than we've done in the other modules. In the other modules, I've stepped through with YouTube videos step by step on how to complete the project. In this case, I'm going to give you an overview and then leave it to you to fill in all the blanks, so to speak, in the process. Give you some more creative freedom, and hopefully you'll find that an enjoyable process. This is the first time I'm running through this idea about doing a project this way, and this idea of a virtual facade mock-up. And so I'm really looking forward to feedback. Like I said, I hope you'll approach it with a positive attitude, and we'll see where we'll get. And I'm open to ideas about refinement and other concepts like that. So to start out with this idea of virtualizing the mock-up, I have a screenshot of what somebody had done in Pinterest to actually just Googled or selected this idea of facade mock-ups. And this is ubiquitous in the industry. When we're talking about complex facades, it's not uncommon to build, or it's common to build a mock-up for appearance, for helping the vendors to decide if they can fabricate, if the fabrication details will be acceptable, for all kinds of stakeholders to visit it and then determine that what has been drawn on paper and modeled and rendered is really going to be the final product when it's made into the artifact, the actual facade. Facades, and I'll touch on this in lecture, hopefully I have, these mock-ups are also used, not this specific mock-up, but other kinds of mock-ups similar to this are used for testing, for performance testing. They may go for seismic testing and or for wind and rain load for leakage testing according to ASTM standards that might be established for that facade element. And what's interesting to note is when you're building up a facade, you just in the idea that you're using all approved materials doesn't guarantee that you have an approvable facade assembly that meets all the codes. So many times there's this reason for having a performance mock-up made. Now, one of the things I wanted to kind of, keep the dialogue open when we build these kind of virtual facades is that the example I give you is a very, how can I say it, traditional punched facade. And I wanted to just give you some examples of non-traditional or more contemporary punched facades, just to make sure that we have an open attitude going into this about the way we can build up these facades. I want to, after I show you a couple of these images, I want to step back and kind of maybe describe this idea about why I want to do this idea of a virtual mock-up as opposed to a physical mock-up. So as you see in these images, there's just all kinds of varieties of punched facades. Once again, the goal of the punch facade is to get us to experiment with facades that have limiting amounts of glazing area, mostly aimed towards the idea of increasing the performance of the building envelope. Less glass, less solar insulation that needs to be air conditioned, less radiant heat that is lost from the building, or less thermal heat that's lost from the building. So in many climates, the punch facade is the highest performing facade, at least for certain elevations of the building. I'm going to show you a couple of details about this idea of, facade complexities, hopefully kind of moving into this concept of tectonics, about, the kind of back and forth with how a facade is made to how it looks, so that we can optimize the performance of it. And really kind of, like I said, discuss this idea of the virtualization, the model making of the facade. Not a physical artifact, but a digital artifact. And, there's limitations, as we're familiar with Revit, in that it's really quite difficult to model the details. And so we tend to avoid that and then draw them in 2D or technical sheets to try and explain the complexities of the system. And I think that's a very poor learning platform. It's okay for making construction documents that way if the ideas are well established, but there are many limitations to the idea of not going to the full level of modeling, even before you go from that virtual mock-up that I'm talking about to an actual really physical mock-up. So I picked up this image. I did a search of this idea of technical drawings because I think I'm not really going to fill in all the blanks about how you're going to mount your panel systems. I'm expecting or anticipating that you'll come up with your own kind of clever way of attaching it. And with that, I'm saying I'm giving you a lot of freedom. It doesn't need to be absolutely correct. It just needs to be a first attempt at how you're going to build up the components and then actually ultimately suspend the components structurally on the facade that you develop, or the structure that's behind that facade. So once again, sorry for the blurry image. I wish I had a sharper one of that one. I just wanted to make sure I got into the presentation, this discussion about attachment systems. And really, that I'm not I'm gonna I'll set you up with a couple of ideas about attachment systems, but depending on the panel system, the type of material you use, your attachment system could be quite unique. And so here's an attachment system that I just pulled out just because it's really quite far out. It's a double glaze system with a clip attachment system, but it's also a sketch, which is really quite beautiful and obviously very descriptive. The limitations here are the sketch is just static. It's very hard to modify any component without having to redraw the entire sketch. But it gets to the kind of concept of this idea of helping people to visualize that. And there are a couple of other, resources I found that had, and I'm expecting you to kind of do the same thing, to pick a facade, maybe a ceramic facade. Let's say we pick a porcelain panel, or you pick a porcelain panel, and then you might find a building that's similar to what you're interested in. You start to develop a facade, and then you may go and search some of the ask for technical drawings on that specific project to see if the architect has put things out in Pinterest or in LinkedIn that shows the way the facade's attached. And if not, you have to kind of wing it and figure those out. But I'm linking you here, or I'm showing you some of this idea about the rich kind of details that are out there available to us just at our fingertips. I also wanted to take you to this site because this is an architecture firm, and that's funny. That link worked just a second ago. Let me see if I'm going to put this on pause and find out what's going on with that link. So I re-hit the link and it turned out to work this time. So I'm not exactly sure what's going on there. But this is a firm, F plus A plus T. And they really have beautiful images of this idea of these kind of BIM modeling that goes to this high level of detail. So we're kind of looking at just some of their screenshots showing that kind of level of construction detail with it. And if we roll down here, typical window facade, and then they actually animate it showing you, this is the kind of, I guess, attempt or look at, I hope that we'll be able to do in our kind of modeling project environment that we're going to work in. It doesn't necessarily have to be as complex as this, but you get the feeling. We still have the idea of a steel frame wall, and then a window assembly, and then an attachment assembly for the veneer system that might go on with it. And in this case, with this idea of a shadow box, or what, I don't know what you exactly call it, how that might be fastened and attached to the assembly. So I thought that was a very nice detail. And they do these other details here. And they really promote this idea of creating a really richer model, a richer BIM model for everybody to share with all the kinds of construction details that are involved in it. And that's quite a departure from where we're working currently with Revit in our BIM environment, in that we draw walls that really have no componentry in them. And so I'm hoping we get a lot out of this kind of exercise. So with that said, I'll go back to the presentation and kind of discuss where we're going with things. Get my mouse over here. Didn't mean to do that. Kind of wanted to click that back to full screen here. There we go. So that's fat architecture, and I think that's the end of the slides. Sorry about that. I wanted to show you the example of the kind of idea I have about deliverables, what I would expect to see in the project. So this is the first image. I've done this this is all inside of Revit using Enscape for rendering, and then importing those images in. Your technique can vary. That's fine. I'm trying to give you as much digital freedom as possible. I really want us to have the experience of doing the difficult model making inside of Revit, so we become just better model makers and able to incorporate richer detail. So the idea of that facade mock-up, once again, that virtualization of a small part of the section of the building. Why I do this, and I'm not saying we're building a whole building, is that this idea of just being able to focus on a few specific components that make up the larger part of a facade system, instead of thinking of a wall as a complete assembly where we need to look at every aspect of it. In this case, we're like avoiding things like corner conditions and that for now, just to make the project more manageable. So some nice things that I think come out of this idea of doing this kind of virtual facade mock-up is the especially when we're using our rendering tools like Enscape. We can actually put on a VR headset. We can put people into the scene and get a real sense for the scale and size of the componentry that we're specifying. And this may be the first time that it becomes apparent if you have an object that's maybe 18 inches or 2-foot size spandrel, just how massive that element feels, the depths, the things that you're actually creating when they're viewed, well, first at the scale of people, but critically, in what most people who think about VR, they think about that's a way of presenting ideas to your client, but it really is a very effective way of experiencing the objects that you create. The idea of stereoscopic vision gives you a great sense of depth. You can understand the mass of something in ways that can't happen in, I don't want to say they can't happen in 2D, but they're enhanced by that 3D stereoscopic type viewing. So I encourage you all to get involved, at least some touch with VR, especially not at the walkthrough level, but even at the component level of the things you create. So some of that level of boring down to the details, and I'm hopefully using that word boring, not figuratively. The clip system, how it attaches to the wall, where the insulation goes. I want you to be clear on where the air gap is. In this case, I've made a larger clip to do that bump out and supported those tracks on it and made a model of that. One model as a family unit and then duplicated and mirrored to support all of those elements. So a lot of that kind of detailing can happen relatively quickly. I've tried to label all the componentry just to give you an indication of what I'd like to see on the deliverable. That idea of thinking about using this as a communication document to others to describe the componentry. And I want to point out the idea of thermal breaks. So this is, you can see this metal structure sticking out into the cold facade or the hot facade, and then that metal transferring that heat back to the building plane, the envelope of the building. And as we've done discussed in lecture, the idea is that we want to make sure that we eliminate as much thermal transfer there. So we insert these items called thermal breaks, which are materials, many times polymers, that have a lower thermal conductivity than the metal, and they tend to disrupt that flow of heat from the facade into the building envelope. So this is kind of a skeletal detail. The next image here is a detail, that same detail now with everything in place and showing the clips and attachments of the tile. And I think the next image is the one that I was most excited to see or be able to generate with inside of the Revit environment. So here I have a section box that I pulled way down on that detail, and it reveals so many of the important aspects of the componentry. If I'd been a little more clever, I could have caught the clip system in its full expression up here, so that would have been visible. I'm also not catching the clip system over here, but we get a great idea of the relationship of these components, that kind of need for that extended aluminum sill. If you look, there's a rich detail in the idea of what the cross section of the window frame extrusion is. You can see the metal framing for the wall assembly, and even things that aren't discussed. For instance, what happens with that inside of the window as it meets this drywall? What kind of detail would happen here? So this is an image that I would love to see on every project that gets submitted. And I've got next to it over my head here a same similar view, but a section of more formal section view of it, just to show you. Now you can see the clips and visualize them, and you get I think a really good sense of how the components fit together. But obviously the 3D model much more descriptive and richer in the information conveyed. And the last image I have here is the idea of thinking about modularity with this. It's inherent in the way that we're kind of structuring this project. It's not necessary that you think in terms of modularity, but I think it's an important added bonus concept. If you can figure out how to put that facade together in ways that can be fabricated in factories and shipped to site, I think that gives you other opportunities as you go through the kind of value engineering and moving towards the actual construction of a building. Now, one more thing I would like to cover is really kind of set you up with the final, I'm going to provide you a kind of a seed document, a Revit file. I call it Facade Lab Start. And I've gone ahead and set up the panels. The panels, I think, are 5 feet by 15 feet or something like that, or 8 feet by 15 feet. And I've stacked those up in a grid. You don't have to use these. These are just pre-constructed that have everything on them, from the steel framing to the insulation. And the idea of the punched wall, obviously the way you would deal with this, before we go, I'm going to click into that and then I'll show you how you can modify it. I've also provided another family element. So this is a generic model, and this one is a generic model family element. And this one I've just kind of deconstructed, so you could actually just grab parts and pieces off of it if you wanted to start more from scratch. And in this case, and this has things that the other one doesn't. This has the terracotta tiles extruded out. I don't want you to use the same terracotta tiles, obviously, but these are things that could be used as a basis of your thinking. The clip system for the terracotta tiles, the bracket, the standoff bracket I've created, and these are all just starts to modifications. Like, for instance, you can make a very unique clip or bracket, but you could reuse my bolts. You could reuse the color and massing of the thermal break. This is an aluminum extrusion, just another object. And then the window frame, and I've shrunk it down here so it looks really kind of dopey, but that's there to be used as an independent item. Now, on the other unit, and I'll double click into this, or actually, yeah, it'll go ahead and edit it. You'll see that this is almost a fully finished. It doesn't have the interior drywall, but this has the steel framing. It has the window to it, and it has the insulation layer. And you can click into any of these. For instance, if we were to, let's see, grab the window. I think I might have the window. And we'll go ahead and sketch and edit the path of the window. Let me go to the front view here. And let's say I wanted to offset a window and have it up high. And let's see if that completes that. Yes, it does. So what didn't go with it was the glass that I've also had embedded within that. But now I've been able to offset and reframe that, and you could imagine doing the same thing with the way you do the openings. And now you reconfigure that module. You also may want to change the size and dimensions of the module. I'm not exactly, like I said, I wasn't sure what this was set at. Yes, it is 8 feet. And let's see what it goes this way. By 15 feet from floor to ceiling. And then there's the slab down here. You may want to include that slab or not. It is an 8-inch deep slab, so that will kind of, those need to, that kind of upsets the module a little bit, because that's really part of the module if you think about it. If the distance between the floor and the ceiling is 15 feet, then the 8-inch has to be added to that at some point. So you may want to just shrink this down so it's tighter into that 15 feet. So this, I hope, is a good start for how you would build off your, a good start to how you could do your project. I've also done something a little bit different here, is that I've created a podium level that's not necessary for the project, but I think this is a more realistic way of thinking about the construction of that facade. Once again, you can move these back down. No need for a podium. I just put the curtain wall glass in to suggest that that might be a way of creating your facade. And it might fit more with the idea about what you have with a punch facade. Maybe it's an urban building with mixed use applications to it. So I think that lays out basically what I would hope to see with the project. Once again, I'll go back and review quickly this idea of the project deliverables. Some nice views showing the overall idea of the mock-up, maybe close-up of scale, a couple of these kind of details, hopefully labeled. I think it's important maybe to bring up the idea of the air gap and other things that might be critical in your for instance, I don't have the air gap labeled here. I don't have the air moisture barrier labeled. So I would, hopefully be delighted to see you advance on the kind of descriptives. And like I said, also that idea of modularity and describing that is an optional aspect. So I'm looking forward to maybe seeing about five or six sheets of your project. And this is a first run through, so if you have any questions or are hesitant to do something, you can reach out with me with email. I'll get back to you right away, and hopefully keep you moving effectively on it, and hopefully you'll find a lot of pleasure in being able to come up with your own unique facade and the details that go along with it.